All right, guys, welcome to April 6th. So we're going to talk about transformations today, and we're getting into the four main types of transformations, which are rotations, reflections, dilations, and what we're going to talk about today, a translation. Okay. So a transformation is just taking a geometric shape and changing its either position, shape, or size. All right. We're also going to talk about orientation, which is another option too. So let's, for instance, if we take dominoes here, we could flip the domino over, which would be an example of a reflection. We could slide the domino without turning it at all over to the side, which would be an example of a translation. Or I could turn the domino, which would be an example of a rotation. All right. The other example that's not on here would be like if you could take a picture of the domino and make it bigger, which would be a dilation. All right. So the original domino you started with before you moved it is referred to as the pre-image. So the pre-image is the original figure before you do anything. All right. So that's the OG figure here. And the other vocabulary we use is the image. So just like when you look in a mirror and you see your image, right? That's your reflection of where you are, where you the original person are. That's your reflection. So the image is the result, the figure you get as a result of the transformation. All right. Next, we're going to hit on this vocab word, so I'm just going to bring it in now, which is called a rigid motion. So a rigid motion, okay, is a transformation that results in a congruent figure, okay, where the image is congruent to the pre-image. So if you get something, when we say congruent, we mean same size, same shape, then we know that you've performed a rigid motion. All right. So the first transformation we're going to talk about today is a translation, which is essentially just a slide. So it's where you take all the vertices of your figure, if it's three-dimensional, if it's like a triangle or a square or a rectangle, and you translate them, you slide them in any other direction. Now what you don't do is you don't turn them. Okay, so I'm not turning this triangle as I move it over. All right. I'm not going to flip the triangle over. I'm going to keep the triangle exactly where it is. I'm just going to slide it over to the left, right, up, down, or one combination of like right and up. Okay. The figure I get is going to be the exact same size and shape. So it is going to be a rigid motion. A word we used to use before Common Core hit was isometry. But this is the same thing as what we now use, which is a rigid motion. Okay, so same size, same shape. Now, when you do a translation, okay, one of the options for rules you'll see is written like this. Okay, so I'm going to write x, comma, y, arrow, and I'm going to do x plus some number, we'll call it a, and y plus some number, we'll call it b. Okay, this a and b tells me how to shift left and right for the first number because I'm affecting the x coordinate, or up and down where it's b, okay, which affects the y coordinate. So all I'm doing is adding or subtracting a number to the x and y coordinate of every point I give you. All right. The second option to write this is a capital T. So a capital T stands for translation, and I'm going to write two small numbers in the subscript. Remember, that means down at the bottom right corner here. And I'm going to write A, comma, B. What this tells me is I'm doing a translation, that's the capital T, of A adding onto the X and B adding onto the Y coordinates for every point I give you. Okay? So those are the two options in terms of notation. So let's actually do number one here. What we're going to do is we're going to graph these points first. So point A is -1, 3, so that's right here. B is 3, 3, which is right here. And C is 2, 1, which is right here. All right. So we're going to label those points A, B, and C. And so what I'm doing is I'm moving x minus 2, which means I'm moving 2 to the left. And then I'm moving y minus 5, so I'm moving 5 down. So I take the first point, A, I go 2 to the left, 1, 2, 3, 4. All right, 5 down, and that's my new point. C is 2 to the left, and then 1, 2, 3, 4, 5 down, and C is 2 to the left, and 1, 2, 3, 4, 5 down. So that's my shape. Now, what I didn't do that I should have done is, since this is a since I'm taking these points, I think this is going to be a triangle. So let's connect these points together to start with. All right. And what I'm labeling is I'm labeling the primes on these points. So now that I've moved the shape, I call this A prime. And B with an apostrophe, we call it B prime, and C prime. And so we want to state the new coordinates. So one way we show our work when we state coordinates is we write the original point, which is -1, 3. I put an arrow over to the right, which indicates a transformation. I call it A prime. And then I go ahead and either read the coordinate, or I go back to the graph and say, okay, this is the point -3 because it's left 3, down 2. So -3, -2. Or I'm going to write down the point, which is 3, 3 for B. And then I'm going to actually do the subtraction. So 3 minus 2 is B prime, which is 1, and 3 minus 5 is -2. And so I don't have to look at the graph to get my point. I can just do the subtraction. And then I can actually check to make sure we got the right point. So that's kind of a good thing to do, is do both. So the next one is 2, 1 for C. And so C prime is going to be 0 and then -4. And we can actually check that that's right, and we're good. Is it a rigid motion? We're going to write yes. And the reason why is since we're going to write triangle, that's our symbol for triangle. It's an actual, we draw a small triangle. It's a terrible triangle, by the way, so let's do this better. Boom, boom, boom. And it was A, B, C. And we're going to write this symbol. It's a squiggly line with 2 equal signs underneath. Okay, so it actually looks like this, though. Okay, so that's what it actually looks like. Squiggly line. That's squiggly line is actually called a tilde, or a tilde. Okay, you Spanish people out there would know that one. And then an equal sign underneath. And so that means congruent. That means the triangles are the same size and same shape. Is congruent to triangle A prime, B prime, C prime. If this wasn't a triangle, we couldn't talk about congruence. Okay, we would just say, yeah, the points look like they're the same, distance apart and all that fun stuff. So congruence. Okay, so same size, same shape. All right, let's go to number 2. So try this one on your own. Pause it, go ahead and do that, and then we'll go over it together. Okay, so using point C, same thing. Now I'm going to make it appear magically. Ready, set, go. So there's CAT. All right. And so we want to do this transformation. So remember, it means we're going to shift everything right 3 and then up 6. Ready? Here we go. And so we've done that here. All right. And then make sure we're doing the coordinates as well. So go ahead and do those. And so we end up with the points positive 2, 3 for C. Okay. -5, -2 for A prime, and T prime is -3, 5. And so once again, is it a rigid motion? And we're going to go ahead and throw down our yes, it is a rigid motion. Okay. Okay. We can say the same thing, like triangle CAT, right, is the same size and shape as triangle C prime, A prime, T prime. That's one option. Okay. Remember we wrote before? Then since they're congruent, it's a rigid motion. Okay. Same size, same shape, or mentioning the fact that it's congruent. Just 2 options for you on how to write that. Okay. Head it over to the next page here. And here we we go. We're going to write the rule for the translation. Okay, so all I really need to do, and I know every single point, okay, is going to shift the exact same amount. So all I have to do is pick two what are called corresponding points. Corresponding means it's in the same position on both the image and the pre-image. So I can pick R and R prime. Those are corresponding, and I can just count. Now remember, don't start from here and move up, okay, because we're starting from R prime, and I want to start from R. So I'm going to start at R and then shift to R prime. So for the left or right, for the X coordinate, I have to shift left 2, okay? And then for the Y coordinate, I have to shift down. And it looks like 5. So it's left 2, okay? And then 1, 2, 3, 5 down. So this means that I'm taking the X coordinate and I'm doing a -2 to it, let 2 to the left, and then 5 down from the Y coordinate. All right? So there's two options for the rule. Okay, so first we have to do, we'll do the coordinates first so we can all be sure. So state the coordinates. So we're going to write R, we're going to read our graph. So it's 1 left, that's -1, up 3. Okay, P is over 2 to the right and up 1. And then Q is over 3 to the right and up 3. And then remember, we're doing an arrow over. Okay, and then we're doing R prime. And so this is -3, and then it's -2. Now, when you're reading these points, be sure that you are very careful, okay, about your scale. So I'm counting the number of moves in the graph, 1, 2 to the right, right? But if this is not counting by 1, then it's technically not 2 to the right. If we're counting by 2, it would be 4 to the right. So make sure you are careful when you are reading your scale here. Okay, P is 2 to the left, and then it's, so that's, well, I'm reading P prime, which is 0, comma, and then 1, 2, 3, -4. And then R prime is -3, that's 3 to the right, left, and then down 2. Okay, so I'm either going to count the move on the graph, or I'm going to count the change that I get from moving from the X coordinate to the Y coordinate. So you see this is going from -1 to 3, which is minusing 2, and then from 3 to -2, that would be -5. So that's how I'm getting this. Or I'm counting, right, 2 to the left, that's -2, down 5 is -5. So either way, I should get the same answer. And there's two ways to write this. There's the X, Y arrow, and then for the X coordinate, it's X -2, comma, Y -5. That's one rule. Or another way to write this is capital T, and then -2, comma, -5. That's it. Okay. This is the same translation though. It's just written two different ways. So let's go ahead and have you guys do 4 and 5 here. Ready, set, go. All right. Now that you got it, let's take a look at the answers. All right, so there's our points. So remember, we're starting from the figure in black here, the PQRS, and we're shifting over to the blue figure P prime, Q prime, R prime, S prime. Now, I didn't do the last question in the alphabetical order, and that's okay. So you can technically name your figure and triangle using any of the points. It just says state the coordinates. It doesn't say like I have to do them in a certain order. So same thing here, stating the coordinates. Okay, it doesn't have to be, it could be R, Q, P, S, that's fine. They're just telling me what the coordinates are in terms of their points. So remember the two ways. We can draw our line over and then down or up, so left and right. This is right, 1, 2, 3, 4, 5, 6, 7, 8. So it's +8. And then down 2, -2. And so there's my rule. Or I can do the counting, right? From 3 to 5, -3 to 5 is +8. And then from 4 to 2 would be our -2, and I can get my rule that way. And you can do this for any of those. You should be able to get the same rule using any of the points. And so we're writing our coordinates x, y becomes x +8, comma, y minus 2, or we're writing our capital T with an 8, comma, negative 2 and a subscript. All right, so number 6 is another type of question they ask, which is after the translation, and there's your pre-image, there's your image, okay, they're giving you both, write the rule. Remember, I only have to look at one specific point, okay? And all we're gonna do is check to see what happened to the x and what happened to the y. So from 3 to 6 is plus 3, from 5 to 2 is minus 3, okay? So the rule was either gonna be x, comma, y, arrow over, which is what I was about to do, and then that's going to be x plus 3, comma, y minus 3, or we're going to write the capital T 3, comma, negative 3. Your choice. Put in both. All right. The second transformation we're going to learn today is called a dilation. A dilation, just like your eyes when you're looking at the light, okay, it either grows or shrinks. Fun fact, if you're in love with someone, when you look at them, your pupils will dilate. Interesting, okay? So a dilation is we're just multiplying by what's called a scale factor, okay? The scale factor is what you're multiplying every one of these points by. Now, geometrically, what I'm doing is kind of like shining a light at a figure. And as the light passes through the vertices, it's going to continue to either grow or shrink, okay? And create a new figure behind it or in front of it. So if I started with this as my image, you can see we're shrinking down to the pre-image, which would be PQR, and vice versa. I'd start with a small one and I grow to a large one, okay? Now the ratio of the sides is where the scale factor comes from. So if this side is 6 and this side is 3, you can see that I've dilated by a scale factor of 2. I've gotten twice as big. All right. So we want to go ahead and graph the image after the dilation. This is a scale factor of 2, and the center is at the origin. What this basically means for us is that if this were a phone and I were to take my fingers and place it right on here and I stretch out, okay, where are you zooming in at? That's your center. So we're always going to be centered at the origin for our purposes. Okay, so we want to list the coordinates of the triangle, multiply by 2, plot the two coordinates. So we're going to go ahead and do a triangle. It says Z. We'll do that first. So Z, you can see, is negative 3, comma 1. P, or should I say G is next. And so G is 0, negative 2. And P, remember carefully your scale. So 1, 2, yep, this is counted by ones, is going to be 2, comma 0. And so now I'm doing a dilation of 2. So I'm going to take all these numbers and I'm going to multiply times 2. Okay, Kate, you can draw it at the end for everybody, okay?
No.
Oh, yeah. Okay, so we're going to double it. So this gives us negative 6, 2. Double this, we get 0 still. And we get negative 4. Nice. And then we take P, we're going to get 4, comma 0. And so we're going to go ahead and graph those.
4, 0, everybody.
Thank you. So we're going to go 6 to the left and then up 2. Okay, that's our first point. We're going to go 0, down 4, and then we're going to go over 2, and then just over 4. Okay, so what I've essentially done is just take the distance from here to Z and double it. Over 3 up 1, over 3 up 1, down 2, down 2, 2 to the right, 2 to the right. Okay, that's what a dilation does. And so I'm going to connect those points together, and there is my triangle. Okay, and so we'll name it. So there's Z prime, P prime, G prime. There's our dilation. So we're just multiplying for dilation. Okay. Now, as you can see, when my scale factor was 2, my figure got bigger. So what do you think is going to happen if I do a scale factor of a half? Yeah, hopefully you said it got smaller, right? Let's actually do it. So go ahead and do this one, and then we'll take a look at it. All right, and then let me bring up the answers. And now. Okay, so we have our original points. So the same points as last time. Now we've divided everything by 2. We've taken it times a half, or divided by 2 times a half, either way. And I end up with -1/2, half, 0, -1, and 1, 0. So this is still 3 over 2, or 1.5, right? 1/2 or 0.5, and then we get those numbers. So go ahead and graph them, and then we got our answer here. Okay, now to indicate a dilation in terms of notation, we use a capital D for dilation, all right? And then what we do is we write down two things. We write down the center. So the center here is the origin. So we can either write O for origin, or I can write down the point 0, 0. All right, so we'll just do the O for now. So we're going to do the O, comma, and then I'm going to write the number I'm multiplying by. So here it would be a half. And same thing here. Dilation, center at the origin, and my scale factor is 2. Okay, so as long as you multiply by a number bigger than 1, it's going to grow and get a new shape where all the points are twice as far away from the center. Okay, if you do a number between 1 and 0, so less than 1, greater than 0, then we're going to get a smaller shape that's closer to the center of the origin. And if I multiply by 1, we don't move at all, and I can't multiply by 0, or I just end up with a point at the center. Okay, and if it's a negative, it actually flips upside down. So we'll talk about reflections tomorrow, though. So on the next page, we're going to go ahead and do these. So go ahead and try these. We'll go over the answers shortly. So go ahead and try these ones on your own. We'll go over the answers together. Okay, so for the first one, we started with the same coordinates, -3, 1. All right, 0, -2, and 2, 0. And we're ending up with the same numbers over here, 6, -2. Well, we're doubling by and multiplying by -2. So 6, -2, 0, 4, -4, 0. So remember, we flipped our shape upside down, and then we made it dilate. Or we could say we dilated first and flipped it upside down. Now, the only problem here is that G prime actually went off of our graph. This is not actually allowed to happen. That's an error on my part because I gave you a graph, right, a grid, and I gave you the scale. So you really couldn't do much about that. Normally, I'll make sure that in the future that we have enough room, or you don't have a scale and you can do your own. All right. Number 4, so same thing. We end up with the points 1.5, -2, 0, 1, -1, 0. So we flip it upside down, we shrink it down by half, and we end up with this shape right here. All right. Number 5, so if the R value is greater than 1, or technically less than -1, we are going to get a bigger figure. It's going to result in an expansion of our coordinates. All right, so anything, and technically the way we would normally write this is we would say if the R value is greater than the absolute value, actually I should say timeout, the absolute value of the R value is bigger than 1. Okay, that's how we could write this, so it's just one thing. So if it's whether it's -2 or +2, when I plug it into the absolute value, I'll get 2. So as long as that number is bigger than 1, we're going to grow. And at the same token, right, if our R value, the absolute value of our R value is in between -0 and 1, so we're going to flip this around. So if the absolute value of R is greater than 0, right, and less than 1 at the same time, then we're going to shrink. Okay, and the figure is going to get smaller. So you could say if R is bigger than 0, less than 1, or bigger than -1, less than 0, we're going to shrink. If the scale factor is negative, remember we're flipping the shape over the x-axis, and then we're going to dilate by our scale factor. Flip that around if you want to, it's okay. And these are the shapes you should have gotten for 7, 8, 9, and 10. Okay, so we're shifting everything left 1 up 4. We're shifting everything right 3 up 3. Okay, same thing for number 9. So now what I'm doing for number 9 is I'm looking at my original shape, which is a solid figure. The dotted line is the image. And I'm saying, how do I get from point A to A prime, or B to B prime, C to C prime? So I'm going left 3, down 4. So that's going to be a x -3, y -4. So either we're writing it like this, or we're writing with our capital T is up to you. Number 10, we can see we're going from V to V prime or U to U prime, whatever the deal is. We're going right 4 down 3. So once again, this is x plus 4, y minus 3 here, okay? Or capital T 4 comma negative 3 in the subscript. That is it for today, guys. Kind of a longer lesson here, but hopefully this is making a little bit of sense. We will do this next year, Geometry 2, but it is also one of the 8th grade standards, so making sure you guys get covered everything this year. All right, guys, that's it from today. I'll see you tomorrow for Transformations Day 2. All right, guys, take care.